Right now in New York City, a mid-rise apartment building is somewhere in the middle of a 3-year construction timeline. Permits, zoning reviews, subcontractor schedules, concrete pours, weather delays, 3 years from the first approval to the first family moving in. On the other side of the planet, a Chinese company just put up a 26-story residential tower in 5 days. Not a prototype, not a demo. A real building where real families live. The gap between those two timelines is not a minor efficiency difference. It is a signal that 2 completely different centuries of construction are running simultaneously on the same planet right now. By the end of this video, you will understand exactly how China's system works, what makes its buildings 10 times more earthquake-resistant than anything concrete produces, how a second company is printing finished houses in 28 hours and 45 minutes from recycled rubble, and what it actually means for the global housing crisis that the technology to solve it already exists, but most of the world refuses to use it. If this is the kind of story you want to understand before it hits the mainstream, hit the like button and subscribe right now. It genuinely helps this channel reach more people. Now, let us get into it. Zhang Yue built his name and his fortune selling central air conditioning systems across China. His company, Broad Group, became one of the largest manufacturers in that space. That was the whole story. A successful industrialist running a successful industrial business. Not chasing headlines, not trying to disrupt anything. Just running a company that was good at one thing and doing it at scale. Then an 8.0 magnitude earthquake tore through Sichuan province in 2008. Nearly 70,000 people lost their lives. Tens of thousands of concrete buildings came apart. Schools collapsed mid-morning with children inside. Hospitals folded. Apartment blocks that families had lived in for years were reduced to rubble in under a minute. Zhang Yue watched the aftermath and could not let go of one simple observation. Concrete is heavy. Concrete is rigid. When the ground shakes hard enough, it does not flex. It shatters. And when it shatters, it takes everything inside with it. The buildings did not fail because they were old or poorly maintained. They failed because the material they were made of was never designed to survive that kind of force. Yet the entire world kept using it, kept pouring it, kept stacking it floor by floor, decade after decade, as if no better option existed. He asked one question out loud: why are we still building this way? That question did not stay abstract for long. He took his entire operation, his engineering team, his factory floor, his supply chain, everything he had spent decades assembling for air conditioning, and pointed all of it at one new goal. A building system that goes up fast, survives almost anything, and never once requires wet concrete on a job site. He did not start from what the construction industry already knew. He started from first principles. What does a building actually need to do? It needs to stand. It needs to stay standing under stress. It needs to be livable. It needs to last. Every assumption beyond those 4 basics was open for questioning. He brought in engineers and manufacturing specialists, not from construction, but from industries already used to building complex things precisely, repeatedly, and at speed inside a factory. Aerospace thinking applied to architecture. Industrial manufacturing logic applied to housing. It took years of failed modules, redesigned joints, and rethought assembly sequences. But when the system finally worked, it worked completely. Here is the part of this story that almost no coverage bothers to properly explain. And once you understand it, the speed stops being shocking and starts being obvious. Everything, every wall, every floor, every balcony, every electrical wire, every water pipe, every ventilation duct gets built inside a factory. Not some of the parts, every single part. The factory itself covers 230,000 square meters. That is roughly 32 football fields under one roof. Each section of a building is assembled into a module about the size of a large shipping container. Walls fold flat for transport. Balconies fold inward. Windows are already fitted. Wiring is already threaded. Plumbing is already connected. By the time a module rolls out of the factory door, it is essentially a finished room. It just needs to be lifted into position and locked to its neighbors. Trucks carry the modules to the site. Cranes lift them into place. Steel bolts lock them together. And the building assembles like flat-pack furniture, except the furniture is 12 stories tall and families are going to raise their children in it. Think about what that actually means for the construction process. Traditional construction is like trying to cook a 5-course meal from raw ingredients in a field, in the wind, with 100 different people handing you things and no 2 batches of ingredients ever quite the same. What Broad Group does is more like running a professional kitchen where every dish is prepped, measured, and tested before service. Then, the finished plates are carried to the table. Same result. Completely different process. And the professional kitchen wins every single time on speed, consistency, and quality. There is no pouring concrete on site. No waiting days for a slab to cure before the next floor can start. No halting work because rain is in the forecast. No coordinating dozens of subcontractors showing up on different days with different materials. The site is not a construction zone. It is an assembly zone. And that single distinction changes everything. Because everything happens inside a factory, quality control works differently too. On a traditional site, mistakes get discovered after concrete has already dried or walls have already gone up. Fixing them is expensive and slow. In a factory, every module is inspected before it ever leaves. The tolerances are tighter. The measurements are exact. When a module arrives on site, you already know it is right. You are not hoping it fits. You are confirming it does. To prove the system could work at full pace, Broad Group set up cameras in Changsha and recorded an entire build from start to finish. 3 cranes, a full crew, 1 continuous shoot. The foundation was already in place. From the first module lifted off a truck to the last bolt tightened on the top floor, 28 hours and 45 minutes. A complete 10-story residential apartment block. The time-lapse spread across the internet within days. Millions of views. Engineers, architects, and developers are all watching the same footage with the same expression. Half the industry said this changes everything. The other half said it was a carefully staged demo that would never survive real-world conditions. Neither side could stop watching. Broad Group's response was not a press release. It was a bigger building. The next project was not 10 stories. It was 57. They called it Mini Sky City. A full mixed-use skyscraper standing 204 meters tall. 800 apartments stacked inside. Office space for 4,000 people. Retail at the base. All modular, all factory built, all assembled on location. 1,200 workers averaged 3 complete floors every single day. Over 90% of the entire structure arrived from the factory already finished, already wired, already connected. Workers on site were not building the building. They were positioning it, locking it together, and moving up to the next level. A conventional skyscraper at that height takes around 2 years. This one took 19 days. And in the process, it eliminated an estimated 15,000 truck deliveries of wet concrete. String those trucks bumper to bumper, and you are looking at a convoy stretching across an entire city. Gone. Replaced by a cleaner, faster, more controlled process that produced a taller building in a fraction of the time. But Mini Sky City was not the end of what was possible. It was just the point where the skeptics ran out of easy arguments. A few years later, a 26-story residential tower called Jingdu went up in just over 5 days. 100 workers on site. A crew small enough to fit on a single bus, raising a building taller than most downtown apartment blocks in less time than most people spend finishing a week at work. At that point, the conversation shifted completely. It was no longer about whether the system works. The footage existed. The buildings existed. People were living in them. The real question became something different entirely. If a building goes up in 28 hours, how long does it actually hold up? That is the question every engineer, every developer, and every future resident eventually asks. And the answer is the part that surprises almost everyone who hears it for the first time. The steel modules Broad Group uses are 10 times lighter than conventional concrete panels and 100 times stronger under load. Not according to a marketing brochure. According to independent testing conducted by the China Academy of Building Research. Every Broad Group structure is rated to survive a magnitude 9 earthquake. That is the kind of earthquake that ranks among the most powerful ever recorded anywhere on the planet. The expected structural lifespan sits at around 1,000 years. Let that land for a second. The building that went up in 28 hours and 45 minutes is engineered to outlast pretty much every concrete structure being built anywhere in the world right now by a factor of 10. Most modern concrete buildings are designed to last between 50 and 100 years. That is the design target. That is what engineers aim for when they pour the foundation. Here is why the gap is so large. Concrete deals with force by resisting it rigidly. When the force exceeds what the material can hold, it cracks. And once it starts cracking, it does not stop. Steel under the same conditions flexes slightly before recovering. The joints in a modular steel building can absorb movement that would fracture a poured concrete structure entirely during an earthquake. That difference is the difference between a building that sways and a building that falls. And because the entire structure is bolted together rather than poured and hardened, it can be taken apart at the end of life and fully recycled. Every module can be unbolted, removed, and either repurposed in a new building or melted down and turned into something else entirely. Construction waste on a Broad Group site drops by over 90% compared to a traditional build. No mountains of leftover concrete, no piles of rebar offcuts, no formwork sitting in a skip for weeks. Just clean, recoverable steel. The speed gets the headlines. The safety numbers get the engineers interested. But the environmental story might genuinely be the most important piece of the whole puzzle. The construction industry, as it currently operates, is one of the largest sources of waste and carbon emissions on the planet. A system that cuts construction waste by 90%, eliminates thousands of concrete truck deliveries per project, and produces a building rated to last 1,000 years is not just a faster way to build. It is a fundamentally different relationship between construction and the environment. Broad Group is only half of this story. Because while they were stacking modules in Changsha, a completely different company in Shanghai was coming at the same problem from a completely different direction. Their method looks less like construction and more like something out of a science fiction film. Winsun does not stack buildings. They print them. Giant nozzles move on programmed tracks, laying down a mixture of recycled construction waste and fast-setting cement. One pass at a time, wall by wall, layer by layer. The same basic logic as a desktop printer putting ink on paper, except the printer is the size of a warehouse. The ink is recycled rubble, and what comes out the other end is a structurally sound, weather-sealed house. In one 24-hour run, Winsun produced 10 complete houses, each one ready to move into. Material use drops between 30 and 60% compared to a conventional build. And because the printer follows a digital file, you can change the design between one house and the next without retooling a factory floor or retraining a crew. You just updated the file. The machine does not care. It just follows the new instructions. Winsun and Broad Group are doing completely different things technically. One stacks pre-built modules. The other extrudes layer upon layer of printed material directly on site. But the logic underneath both methods is identical. Stop building by hand in the open air under unpredictable conditions. Move construction into systems that are controlled, repeatable, and automated from the start. One company stacks, the other prints. Both are eliminating the biggest bottlenecks that have held construction back for generations. And together, they sit inside a market growing faster than most people realize. The global modular construction market hit roughly $95 billion in 2025. Projections put it past $175 billion by 2034. The Chinese government alone has committed over $1 trillion to building infrastructure in the current planning cycle. Singapore has made modular construction mandatory for public housing. The UK has committed billions to off-site construction programs. The policy is institutional. The money is real. So why is most of the world still building exactly the way it did 50 years ago? Here is the honest answer. Building codes in most countries were written for concrete and timber, not factory-assembled steel modules. Entire supply chains are locked into the existing system and have no obvious financial reason to help dismantle it. Developers who have worked the same way for decades are cautious about switching, when the risk of a failed experiment falls entirely on them. And the most ambitious project Broad Group ever announced, one that would have stood among the tallest buildings on the planet, never broke ground. Not because the engineering was not ready, because the regulatory and financial environment around it was not ready. That gap between what is technically possible and what the systems currently in place will allow is the real story underneath all of this. But that gap is closing. The economics are too compelling to ignore forever. The housing pressure is too intense to keep deferring. Right now, the global housing shortage sits at an estimated 100 million units, and it is still climbing. Construction costs are rising in every major economy. The average age of a construction worker in the United States is over 40, and the pipeline is not replacing them. The direction that the gap is closing is not back toward the concrete. Meanwhile, China puts up a 26-story tower in 5 days. A mid-rise apartment block in London or New York takes 3 years from the first permit to handing over the keys. Same planet, same decade, completely different centuries. A man who spent his career cooling office buildings watched an earthquake flatten 70,000 concrete structures and asked why we were still building that way. He built a factory, redesigned the entire process from scratch, and put up a 10-story apartment block in less than a day. Someone else pointed a giant printer at a pile of recycled rubble and produced 10 houses in 24 hours. The new way is already faster, stronger, safer, cheaper, and better for the planet. If this video gave you a genuinely new way of looking at the buildings around you, hit the like button and subscribe so you never miss what we cover next. Turn on notifications because these stories move fast. Now here is the question I want you to think about and answer in the comments. If a building that went up in 28 hours is rated to last 1,000 years, what does that say about every concrete building sitting on your street right now? Drop your answer below. I read every single comment, and I genuinely want to know what you think.